Welcome to this explainer. Whenever we picture modern air superiority, our minds almost instinctively jump straight to the movies, right? We've all completely bought into this cinematic myth of the lone maverick pilot. We picture them soaring through the clouds, relying on pure instinct and lightning-fast reflexes to win the day. And hey, it's an incredibly captivating image. But when you actually look at the raw data and the real architecture behind modern aviation, you realize pretty quickly that the Hollywood narrative is missing the absolute most critical piece of the puzzle. We are talking about aircraft that generate terabytes, literally terabytes, of telemetry and sensor data every single hour. Managing that massive volume of information while traveling at supersonic speeds, well, that requires a staggeringly complex, totally invisible architecture down on the ground. So today, we are going to deconstruct that myth and uncover the incredibly orchestrated reality of what actually makes modern air operations possible. Okay, let's dive into this. It really makes you wonder, with absolutely everything moving at Mach speed, who is actually in control up there? We kind of have to fundamentally reconsider this traditional idea of the lone fighter pilot calling all the shots. Because the reality, modern airspace is just vastly too complex. It's shifting incredibly fast, and it is completely saturated with a staggering amount of digital information. For any single person in a cockpit to process all of that alone? No way. Imagine trying to dodge incoming threats, manage your fuel consumption, and monitor radar signatures all at exactly the same time. Actually, scratch that. It's not just hard, it is physically and cognitively impossible to maintain absolute mastery of that environment from a single seat. The person in the sky is absolutely executing the physical maneuvers, for sure, but the true control, the grand strategy, and that total environmental mastery actually originates from somewhere else entirely.
We naturally tend to think of the pilot as the ultimate authority, right? Like they are the edge of the spear, the physical muscle executing the mission. But here's the thing. That muscle is entirely dependent on a vastly more complex nervous system that's sitting safely on the ground. A pilot's field of vision, even with all those ultra-advanced onboard sensors, is fundamentally limited by basic physics and the curvature of the Earth. They absolutely need a wider perspective. So if the pilot is the physical muscle, the command center is the nervous system. Modern air power is definitely not some singular heroic act happening tens of thousands of feet in the air. It's like a giant puzzle coming together. It is a massively collaborative, highly synchronized effort. Without the heavy lifting, the immense data crunching, and the strategic overwatch happening on the ground, that incredible muscle up in the sky is essentially just flying blind.
And this brilliantly illustrates what we're talking about. Think of the command center as the central brain behind the entire operation. It is a very abstract, highly technical environment, sure, but that metaphor of a biological brain makes the reality so much easier to grasp. Just like your own brain takes in sensory information from your eyes, your ears, and your sense of touch to tell your body exactly how to react to a sudden change in your environment, the command center processes literal mountains of incoming digital information. We are talking about synthesizing gigabytes of encrypted voice channels, live drone video feeds, and deeply complex telemetry every single second. It is the centralized hub where thousands of seemingly disconnected, invisible data points are instantly turned into actionable, life-saving intelligence to direct these incredibly complex missions. Now, what's really interesting about this slide is how that brain actually processes all of that information. It does this through something known as sensor fusion. Imagine the sheer mind-bending challenge of trying to synthesize multiple, absolutely massive, distinct data feeds into one cohesive reality. You've got ground-based radar tracking hyper-fast movement, orbital satellites providing a massive macro view from space, direct telemetry from the aircraft themselves, and deeply complex, constantly shifting weather systems. If a human tried to interpret all four of these raw data streams separately, it would result in pure, unadulterated cognitive overload. The command center's job is to solve this by aligning these inputs. They beautifully reconcile the orbital data with fast-moving radar pings and atmospheric changes to build a single, unified, low-latency operational picture. It essentially transforms pure chaos into a crystal-clear, real-time, holographic view of the battle space. But hey, it is not just machines and algorithms doing all the heavy lifting here. The human element is where the true pressure really lies. Imagine a scenario for a second, where an unidentified bogey suddenly enters restricted airspace. Inside that command center, teams of highly trained specialists immediately execute a meticulously synchronized sequence. Instantly, the airspace is heavily monitored, with operators keeping an incredibly vigilant eye on every shifting blip. Simultaneously, communications are coordinated to instantly clear out friendly traffic and secure the frequencies. Then, aircraft positions are meticulously tracked to vector and intercept. They know exactly where every single asset is, down to the absolute millisecond.
And all of this intense, high-stakes coordination culminates in supporting decision-making, giving leadership the exact clarity they need to authorize a split-second literal life or death choice.
Let's move on and see how this builds, because none of that internal coordination matters, even a little bit, if the intelligence can't instantly reach the people who actually need it. This requires incredibly fast, highly secure tactical data networks. Think of these networks as the neural pathways transmitting impulses at the speed of light. They share vital information instantaneously across 3 key interconnected nodes: the command centers analyzing the data, the air bases launching the operations, and the aircraft executing the mission up in the sky. The sheer technical challenge here is maintaining near zero latency. I mean, if a data link drops, or if there's even a microsecond of lag while bouncing encrypted data between the ground, the air, and orbit, the entire operational picture just falls apart. It absolutely requires a continuous, unbroken loop of rapid communication to ensure everyone is acting on the exact same intelligence.
So what does this all mean? All of those immense data feeds, the high-pressure specialists, and those zero latency networks exist to achieve one ultimate goal: situational awareness. Now, I know that might sound like a corporate buzzword or some dry military jargon, but it is literally the holy grail of modern operations. It is the ultimate state of knowing exactly what is happening around you at every conceivable level. To understand why this is so absolutely crucial, just think about the alternative. A lack of situational awareness doesn't just mean a missed objective. It can easily result in a friendly fire incident or flying completely blindly into an ambush. With absolute situational awareness, however, a commander can see the entire chessboard before the adversary even realizes they are playing a game. It is the clarity that allows leaders to safely and effectively orchestrate incredibly complex operations across vast geographic areas. So the crucial point is this: grasping this whole concept requires a fundamental shift in perspective. To quote our source directly here, modern air power isn't just about advanced aircraft. It's also about the technology and teamwork inside the command center. And that hits the nail on the head. No matter how incredibly fast a 5th-generation jet is, or how stealthy its aerodynamic design might be, its true power is completely unlocked by the brilliant minds and the staggering technological infrastructure supporting it from the ground. It's a fascinating realization that teamwork, massive data processing, and invisible digital architecture are the true, undeniable drivers behind the whole shebang. Everything spectacular that happens up in the clouds. Which leaves us with a rather profound thought to wrap up our explainer today. When you consider the sheer volume of data being processed, the vital split-second decision-making happening in those dark rooms on the ground, and the continuous strategic guidance provided by these invisible networks, in modern operations, is the true pilot actually on the ground? It is a fascinating question that completely upends absolutely everything pop culture has taught us about aerospace dynamics. So, the next time you look up and see a jet streak across the sky, just remember the massive invisible brain working tirelessly down the low to make that flight possible. Thanks for joining me on this explainer, and keep looking up.